Welcome to another class with Ming. Today we talk about box and whisker plot, and the question that we are asking is how can we better represent our statistics on quartiles? Here is an example of a box and whisker plot. Given a set of data that you have arranged from smallest to largest, for example, as seen here, the range is the largest value in your data set minus the smallest value in your data set. So in this particular case, the range is 7 minus 1, which is 6. The median in this case is 3. The first quartile is 2, and the third quartile is 5. So the interquartile range for this set of data is just going to be 3. Finally, we have another concept called quartile deviation, which is basically the interquartile range divided by 2. So in this case, it's 3 divided by 2, or 1.5. I want to start by pausing and attempting question 2 for finding the range, interquartile range, and the quartile deviation for these two set of data. Welcome back. Here I've done the analysis. I found that the median here is 21, Q1 is 8, Q3 is 25. So now we look at the range. The range is the largest number, which is 40, minus the smallest number, which is 2. So 40 minus 2 is 38. So the range is 38. The interquartile range is Q3 minus Q1, or 25 minus 8, which is 17. Quartile deviation is basically the interquartile range divided by 2. So in this case, it's 17 divided by 2, or 8.5. We can plot the values that we obtained previously onto a graph paper. For example, the minimum value is here, is 2, and the maximum value is 40. And then we put in the median, which is here, a line, and then 8 for Q1, and then Q3 is 25. This particular box here, this is the interquartile range, the length of this box. This particular representation is called box and whisker plot, and it helps us to see graphically how the data is distributed. So we can see now that there's a kind of some very big data on this side, that is 40, and the median here is kind of like skew towards the larger number because of this thing here. And but 50% of the data is actually in this side, to the lower end. So this set of data is kind of skew because here 25% of the data is between 8 to 20, and another 25% of the data is between 20 to 25. And the interquartile range basically represents 50% of the data is actually skewed towards the lower end of the distribution. So box and whisker plot give us a graphical representation on how the data are distributed. Is it skewed and or not? And where are most of the data are concentrated? So the interquartile range tells us where the middle 50% of the data are distributed. Welcome back. Now you may want to pause and attempt these questions up here for this set of data. Welcome back. So the median is between 5 and 6, that is 5.5 over here. And max is 15, mean is 1, so mean is 1, max is 15. This is Q1 over here, number 5, 7 is Q3. So you should have a diagram like this. What the range is 14, 50% of data is actually between 5 and 7 over here. And the median is actually towards the lower end of the data distribution. Welcome back. Here I put the two box and whisker plots together. The range here for the first set of data is 39, which is a lot larger than the range for the second set of data, which is only 14 over here. And the interquartile range for the first set of data, the length of this box is 17, whereas the interquartile range for the second part is only 2. That means 50%, the middle 50% in the first set of data is spread out a lot more compared to the spread of the 50% in the second set of the data, the 50% in the middle. So box and whisker plot tell us about the spread of the data between the max and mean, and also the middle 50%. The middle 50% here is represented by the interquartile range. Write in your notebook the meaning and the use of a box and whisker plot, and you may want to share this with your friend and teacher. Thank you very much for watching.